Okay, so let's take a look at number 20 and let's see if we can simplify this. Well, the first thing I see is that there's a square root in the denominator of this fraction, and we can't have a square root here. So what we're going to have to do is something called rationalizing the denominator. What that means is we're going to multiply the top and the bottom of this fraction by something that will get rid of this square root in the bottom. So in a different color, I'll write in yellow, we're going to multiply by, now to get rid of this square root in the denominator, I'm going to have to do something that's called the difference of two squares. Now when you have something like this, uh, I'll call it a plus b. So a here is like your 2x, and b here is like your 5 times square root of x cubed. If I multiply it by the same thing, but instead with a minus here, what I get is a squared minus b squared. So this is what happens when I multiply by what is called the complement. So here's my a plus b, and when I multiply by this minus 5 root x cubed, I will have the first term squared minus the second term squared. And this is great because the square here will get rid of the square root, just like what we want. So I will multiply this bottom part here by 2x minus 5 square root of x cubed. Now, of course, because I don't want to alter the value of my fraction, what I do to the bottom I have to do to the top, therefore I put this also here on top, 2x minus 5 square root of x cubed. So by doing this, it's like I'm multiplying by 1, right? Because something divided by itself is 1. So it's like I'm multiplying by 1, but what I'm really doing is I'm changing the what we see inside the fraction to something that we can work with better. Now, um, the bottom is going to look like this. I'm gonna write again in a different color. The bottom is going to be the first term times the second term, so that's 4 times x squared. So this is the first term squared minus this term times that term is 5 squared is 25. X square root of x cubed times square root of x cubed is just x cubed. So as we see here, we ended up in the denominator with the first term squared minus the second term squared. And now there's no more square root. Unfortunately, we do have square roots in the top, and what we're going to have to do now is FOIL these two numerators with each other to find out what is on the top here on the numerator. So let's see, let's rewrite this over here. We have 3x squared plus square root of 5x. That's being multiplied to 2x minus 5 square root of x cubed. And what I'm doing now is 3x squared times 2x, that's 6x cubed. And now 3x squared times 5 square root of x cubed is 3 times 5 is, and there's a negative, so that becomes negative 15 x squared times square root of x cubed. And now square root of 5x times 2x is 2. So plus 2 times the square root, 2 times x times the square root of 5x, right? So 2x times this. And now this last term times the last term over here is negative. There's a 5 in front. And then there's a square root of x cubed. And then there's times the square root of 5x. So this is what we get in the numerator. Let's see if there's anything we could clean up a little bit. I see over here that I've got two square roots multiplied by each other. That means that I can That means that I can put one big square root and then multiply the things that are under the square root together. So I can rewrite this as 6x cubed minus 15x squared square root of x cubed plus 2x square root of 5x minus 5 times, and here's the big square root, and under the square root I have x cubed times 5x. So that's just 5x to the power of 4. I could simplify that a bit more because look here, I have x to the power of 4, and I can take the x's out of the square root because I have an even power here. So this becomes 6x cubed minus 15x squared square root of x cubed plus 2x square root of 5x minus, and I have a 5x squared now because when I take this out over here, the power gets halved, so the 4 becomes a 2. And what's left under the square root? Just the 5. Okay, great. So now let's put this on top here in the numerator. I'll write it in the light green. So I have 6x cubed minus 15x squared square root of x cubed plus 2x square root of 5x minus 5x squared square root of 5. Okay, that's great. I see that there are x terms um, in every, um, there's an x term in every element here on top, so let's pull out at least one x. So this becomes, let's factor out an x. This is equal to x times, brackets, 6x squared minus 15x square root of x cubed plus um, 2x, oops, 2 2, oh yeah, the x is gone, okay, so square root of 5x minus 5, one of the x's go away, so this 2 becomes a 1, square root of 5. And in the denominator, there's x squared here and x cubed here, so I can factor out at least x squared, so I'll put x squared here, and this leaves me with 4 minus 25x in these brackets here. Now I've got an x on top and an x squared on the bottom. I can reduce this a bit further, so what I'm left with is that very long and annoying bracket to write, 6x squared minus 15x times x cubed plus 2 times the square root of 5x minus 5x root 5 divided by x times 4 minus 25x. So this top x cancels with one of the two x's on the bottom, so I still have one x left here on the bottom. And now as I scan the top over here, I don't think I can factor anything out. There's nothing left for me to factor out as far as I can tell, so I think I've reduced it as far as I can. Um, so I'll just leave it as that for now. Yeah,